Hey class, what's new? See over lambda. Well, this is part two. I realized I ran out of time as I was working on boron. So let's kind of review and see where boron is. Boron is on your periodic table way over here in part or element number 5. And notice it's in the second energy level and it's in the p block. So we came up with the electron configuration of placing all 5 electrons as 1s2, 2s2, 2p1. So that's where I think I was cut off on the last video series there or whatever, and now we need to do the orbital notation for boron. So, as we said before, if I have an s orbital, I have one blank for that s orbital, and I call it 1s. And then I have the second s, and here's 2s with 1 dash. That's this one. But what do I do with the p? How many p shapes are there? Let me go back up to here. There are 1, 2, 3 p shapes right here. So that's how many blanks I draw for any time you have a p configuration. So I'm going to go 1, 2, 3. And just like the last time when we label the underneath the blanks, we need to label these as well. I usually put it underneath the middle blank and I go 2p, and that represents all 3 of the p dashes that I just drew. Now, how many p electrons do I have? Just 1. Is it okay that I have 2 blank orbitals? Sure, not a problem. That just means that they are available, but they're not being occupied. Okay, let's go to do do element carbon next. So I look at my periodic table, and here is carbon. It is also in the p block, has atomic number of 6. So I need to place all 6 electrons. We've got my board going. So it has 6 electrons. The first 2 electrons are 1s2. The next 2 electrons are 2s2. And now the next 2 electrons, let's go back to my periodic table, it's in the 2p block. So I go p1, p2. Okay, so it is, wrong one. There we go. All right, so it's 1s2, 2s2, 2p2. So how do I do the orbital notation? 1s2, I make my arrows kind of half arrows at this point to make it go faster. Up, down, and now what? I still have those 3 blanks for p, and watch what happens. I'll have 1 arrow going up. And where does the other arrow, the second electron, go? Does it go in that same orbital? No. It's kind of like having empty bedrooms. I bet if your parents have more kids and empty bedrooms, they aren't going to squish both kids in one bedroom if they have 2 more empty ones. Same idea here. So instead of putting the arrow going down in the first blank, you're going to put the next one going up. So you're going to fill each of the orbitals first with a single electron, and when we get to that 4th electron, we'll go back and pair it with the first one at 2p. So why don't you go ahead and do nitrogen on your own? Okay, hopefully that was enough time. So nitrogen has 7 electrons and 1s2, 2s2. I hope you wrote 2p3. Because remember what I said earlier, if I were to add 2 plus 2 plus 3, that should always add up to the total number of electrons. So how do I do the orbital notation? It's very similar to the other one. But now I need to place 3 electrons in the p orbital. So I go 1, 2, 3. Now oxygen is where we come up with the one that will have that 4th electron. So if you have 8 electrons in oxygen, 1s2, 2s2, 2p4. Once again, 2 plus 2 plus 4 adds up to 8. Okay, so I need to place the electrons. You'll notice there's a lot of repetition now once you really get going. That you always start off with 1s2, 2s2, and this time we have 2p4. So I'm going to put up, 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 and now my fourth electron goes down. So that's when they're in opposite spins and they can coexist in that orbital. Will you go ahead and do fluorine and neon? And maybe Mr. Reef can hit the pause button. Okay, so hopefully you are done. So fluorine has 9 electrons, 1s2, 2s2, 2p5. Looks a lot like oxygen, but instead of having 4 in the p level, it will have 5. 1, 2, 3 blanks for the p. Up, 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 down, down. And then neon has 10. 1s2, 2s2, 2p6. 1s, 2s. Went ahead of myself. And then 2p. Up, 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 down, down, down. Now neon is kind of special there because notice, can I put anything more in that p orbital? And the answer is no. I'm filled with that p orbital. I am done with that second energy shell. So if you look back at this sheet here, once my 6 electrons are filled in the 2p, so if I do something like this, it's done. I can't go anymore. So once my second energy level is finished, where do I go next? I go to the 3s. Look at your periodic table. Notice where neon is. It's all the way to the total right. You are done with that second energy level. So where do you find sodium? Sodium's right here in the third energy shell. It's in the S subshell. So that's what we need to do for sodium. Okay, so it has 11 electrons, 1s2, 2s2, 2p6. That is your first 10 electrons that we just did, and now add 3s1. Okay, now I need to do all the arrows. I'm going to kind of come down here because I'm going to run out of room. 1s2, 2s2, 2p6, and then 3s1. Go ahead and do magnesium. All right, hopefully you had enough time. So you have 12 electrons, 1s2, 2s2, 2p6, 3s2. Again, notice the repetition. You always start off with 1s2, 2s2, 2p6, up, 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 down, 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 and now we have 3s up, down. But we're not done with that third energy shell, are we? So if I look back at my periodic table, when you are done with magnesium, where do you go next? You go to the 3p shell. That's where aluminum is in the 3p shell. So now to do the electron configuration of this, has 13 electrons, 1s2, 2s2, 2p6, 3s2, 3p1. And yes, you need to do all this. It's going to get bigger and bigger, and you're probably complaining, do you really have to do all this? And right now the answer is yes, you do. There is a shortcut, but I'm not going to show you the shortcut until I know you can do the full electron configuration and the full orbital notation. When you've proven to me you can do all this, I will show you the shortcut. So now we're left with 3p1. Here's my 3p1. So again, I'm going to put that 1 electron and I'm going to make it go up. Okay. Go ahead and if the sub can pause it, go ahead and fill out silicon, phosphorus, and argon. Do those 3 if you would. All hopefully the sub has given you enough time to practice this on your own. Let's see how you did. Silicon has 14, 1s2, 2s2, 2p6, 3s2, 3p2. 1s up, down, 2s up, down, 2p up, 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 down, 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 3s2 up, down, 3p once again, up, up, and that's it. Phosphorus has 15, 1s2, 2s2, 2p6, 3s2, 3p3. Now, instead of spending the time writing this all out again, I'm just going to add that third electron, and it's going to go here. Now, argon, notice I skipped argon is number 18. 1s2, 2s2, 2p6, 3s2, 3p6. So instead of rewriting the orbital notation, for now you guys should have written the whole thing out though. I will add the extra electrons. And notice that argon is now in the same boat as neon was. Neon was a filled shell, and now so is argon. So where do you go after argon? You have finished that 3p shell. Well, where's the next place to go is in the fourth shell. And that's what this is showing us too. Once you get done with the 3p shell, you put all your 6 electrons in there. Where do you go next? You go to 4s. And so that's what you do when you hit potassium. But now, I think there's one more down there, like scandium. Let's go ahead and look at scandium. Scandium on your periodic table has a total of 21 electrons. So we need to place all 21. We'll start off 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. That's when you got the calcium. But wait a minute, where is scandium? Look at this sheet right here. When you have finished 4s2, you have done the potassium, you've done the calcium. What is the next highest energy level? It is the 3D. It is not the 4D, it is the 3D. So you need to fill in the 3D shell first. Remember what we said about this particular chart, that if you have the second energy level, you have 2 subshells, 2s, 2p. If you have the third energy shell, you have 3s, 3p, and 3d. So you do need to fill in that D shell. It just happens to have higher energy than the 4s. So now we're here, and when we are done with scandium with 4s2, you have to go to 3d1. And again, if you add 2 plus 2, that's 4, plus 6 is 10, plus 2 is 12, plus 6 is 18, plus 2 is 20, plus 1 more is, yes, 21. So let me show you now how to do the orbital notation. I'll write the whole thing out. Here's 1s2, 2s2, 2p up, 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 down, 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 2p6, 3s2, 3p6, up, 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 down, down, down. So then we have the 4s2, but now the question is, how many lines do I write for D? Well, if you go back to this page in your notes where I showed you the orbitals, how many D orbitals are there? I count 5. So whenever you hit the D orbital, guess what you're going to have to do is write down 5 dashes. So after 4s2, 1, 2, 3, 4, 5. This is your 3D, and I just put in 1. Now cobalt, hopefully you can do on your own, and then try bromine, okay? I hope this helped. If you need to hear anything again, go home and watch it on YouTube. Thanks, have a great day.